Hello! In this bonus video, we will be going over the script for the ball scene in more depth. Hey everyone, just wanted to go through a quick rundown of the code in this game, as I feel like I kind of rushed through it in the other videos to keep them shorter. In the future, I will explain the code as it is being written, even if it means a longer video. Okay, so our script starts by creating our onReady variables, which just access child nodes in the scene. Next, we create our constants to represent values that cannot be changed in our script. Then we're going to create a couple regular variables that are just Boolean values that we'll use as flags throughout the script. Next, we're going to move on to our physics process function, which is where we will call a majority of our functions that we created in this script. Okay, so we start by initializing our default velocity value to 0.0. Next, we use the moveToward function to gradually adjust our velocity towards 0, slowing down over time based on the speed constant. This creates a smooth deceleration effect. In this next area, we are simply calling all the functions that we wrote in the body of the script. We use the moveAndSlide function to move our ball based on the calculated velocity. If the character collides with another object, it will automatically slide along the surface rather than coming to an abrupt stop. This provides more natural movement and prevents characters from getting stuck on obstacles. Okay, so this next block of code has to do with the tick timer sound. If the timer hasn't been called yet, check if the dial is rotating. Start the tick timer if the dial is rotating and set timer called to true to prevent this block from executing again until it's reset. Moving on to our apply gravity function, we're going to first check if the ball is not on the floor, so if it's in the air. And then we're going to increase the y component of our velocity vector to simulate gravity. The y component is affected by gravity, and we multiply it by delta to ensure smooth and frame rate independent motion. To prevent the ball from falling too fast or floating upward uncontrollably, we clamp the y velocity to a specific range defined by the negative jump force and jump force. This limits the maximum speed at which the ball can fall or rise due to gravity. Okay, and then we have our apply friction function, which just simulates friction. So to simulate friction, we multiply the current velocity of the ball by a friction factor. This will gradually reduce the speed of the ball over time, giving it a more realistic feel. Okay, moving on to our update shoot ability function. This function will dictate our ability to shoot or launch the ball in the direction of the dial. So, if we have almost stopped moving, we can shoot again. And if we are still moving, we can't shoot yet. Alright, next we have the update exclamation visibility function. This function will provide a visual representation of when we are able to shoot again. Because can shoot represents a Boolean value, we can just set our exclamation visibility to that. Okay, so for the start shooting function, when this function is called, we will call the start rotation function from the dial script. Next, we set the dial sprite to be visible here so the player can choose a direction to launch in. And then we enable our raycast here so that it can find a collision with one of the bricks. Now in the stop shooting function, we stop the tick timer to prevent any further ticking sounds, and then we start the shoot timer to manage the cooldown period for shooting. We also stop the dial from rotating, and then we make the dial invisible until the next shot is ready. Okay, and finally, we set our velocity to the return value of the calculate initial velocity function. And for the calculate initial velocity function, if the raycast is colliding with an object, calculate the direction from the player's position to the collision point and normalize it to get the unit vector in that direction. Then we multiply this speed to set the initial velocity for the shot. Otherwise, we return 0 velocity. Okay, so in the shoot function, we're going to check to make sure that the ball is not moving. So I didn't make it so that you have to be completely stopped. but if we are almost stopped moving, then we can shoot again. So we check if we can shoot. If we can, we check for the player input. When the touch action is pressed, we start shooting or rotating the dial to select a direction. When the touch action is released, play the shooting sound and stop the shooting process. Okay, and lastly, we have the functions that we connected as signals. So we have the on shoot timer timeout. So what this will do is disable the raycast to prevent further collision detection and reset the timer called flag so the timer can be started again when the dial rotates. Next, we have the on tick timer timeout function. So this will play the ticking sound effect whenever the tick timer times out. This will indicate that time is passing or that a countdown is active. Alright, and finally we have our on ball area body entered function. So here we're going to check if the body that the ball has collided with is not part of the not wall group. If it's not, then it must be a wall, so we'll play the wall collision sound effect. Okay, so now we're going to go over the dial script. So we start by setting a few variables. We have our rotating boolean and then our rotation speed, which is the speed at which the dial will rotate in degrees per second. Alright, so in our process function, if the rotating flag is true, apply a rotation to the dial. So if rotating, rotate the dial by converting the desired rotation speed in degrees to radians, and then multiply the speed by delta to ensure frame-independent motion. And then we have a few very simple functions. Start rotation. So we're going to start the rotation by setting the rotating flag to true, and then we have stop rotation, which will stop rotation by setting the rotating flag to false. And that is all for the goals scripts breakdown. Okay, well that's it for the goals series. Let me know in the comments if you'd like me to expand on the series at some point to make it a full game. I have a few ideas for the next series, but I'd love to hear from the viewers about which options would be most in demand. So far the options are a rock, paper, scissors game that will teach UI concepts as well as turn-based logic, a visual novel / dungeon crawler that will teach the use of a dialogue system as well as turn-based logic, a side-to-side shooter game with simplified controls, and a juicy text-based game that will teach UI concepts, dialogue system, and branching paths. Let me know which one you'd like to see the most. I will make a poll about it soon as well. Until next time, folks.